This video is based on a previous video that described a common bipolar junction transistor current mirror. It will describe three basic circuits that use current mirrors. To recap, the current mirror is an inverting constant current sink with two bipolar transistors. The collector current through the first transistor is mirrored through that of the second transistor. Here are a few equations derived from the previous video that show how the output current through the load is related to that through the program resistor. Note that you don't have to use the same voltage source for the reference resistor as you do for the output load, as shown by this circuit that has a 12-volt source at the input and a 20-volt source at the output, as long as they both share the same ground. So the first circuit I want to show you that uses a current mirror is the buffered output current mirror. This is the basic current mirror here, and this is your program resistor. The gain of this transistor right here amplifies the current through the collector of this transistor. Right now this simulator is set for a gain of 100, so this program resistor is set so that we have 11 milliamps passing through this output transistor, and that 11 milliamps, based on the beta of this transistor, is translated to a 1.1 amp output current through the load. This becomes useful if you want to control, obviously, a higher amount of current by using a lower amount of current at the input. Here's another circuit. This is a current mirror-based, current-limited voltage regulator, just like that of a bench power supply. It builds on the previously described circuit and just adds a voltage regulator. Simply put, the output is regulated until the preset current limit is exceeded. At that point, Q3 here will develop a large voltage drop from collector to emitter, and in an attempt to maintain the constant current. In doing so, the input voltage here to the regulator drops below the minimum needed to maintain the regulated output voltage, just like what would happen with a current limited bench supply. You also might notice that this version employs a current reference buffer here. This transistor allows you to, based on the beta of this transistor, to set the supply's output current by supplying a current in the order of microamps. This could be achieved by using a microcontroller and a D-to-A converter. The D-to-A converter could be used to control the voltage at the top of this reference resistor and thus the current through this resistor, and ultimately the current limit at the output of this buffer transistor here. Note that this voltage regulator employs a simple senior diode and a common emitter transistor amplifier. The reason for this is that this simulator does not have a voltage regulator in its inventory of parts. There are certainly many ways to implement a current limited supply. This one just shows how a current mirror could be the basis for some of them. For the circuit as shown, the output current limit value for high beta transistors would be approximately the current through this reference resistor multiplied by the beta of this buffer transistor multiplied by the buffer of this output transistor here. And that is shown by this formula. This next circuit is about amplifier biasing. It is a high voltage gain common emitter amplifier. Please note that this circuit was just cobbled together on a simulator only to illustrate the concept without much thought going into the values of these components. By maintaining a constant current through the collector, you have an active rather than a passive load. This yields a very high voltage gain because an ideal current source has infinite resistance. The current mirror serves as this constant current source. This is a DC blocking capacitor. You'll have some biasing resistors here that depend on your design, of course. This resistor provides negative feedback because without it, the voltage gain would otherwise be so high that you would end up with a square wave output from simply a 1 millivolt peak-to-peak input signal. The input of this particular amplifier is set at 1 millivolt peak to peak. The output is a 3 volt peak to peak sine wave, which, based on a 1 millivolt peak to peak input signal, represents a voltage gain of 3000. If I reduce the input signal to 0.5 millivolts peak to peak instead of 1 millivolt peak to peak, our output signal has a swing of about 1.5 volts peak to peak, which shows that our voltage gain of 3000 is being maintained even at such a low input signal. So this arrangement here allows you to take an extremely small input signal and amplify it by a factor of 3000, even though the transistor itself only has a beta or gain of 100. So those are a few current mirror-based circuits that I thought you might find interesting. Thanks for watching.
I hope you found this video interesting and informative. If you did, please like this video and subscribe to the channel. For more detailed information on this project, as well as recommended breadboarding equipment, best practices, and safety tips, please go to breadboardcircuits.com.